मेरी आवाज सुन रही है? अब बंद नहीं करना। Welcome everyone. Today is the second day of faculty development program on exploring multidisciplinary avenues in pharmaceutical education and research. So I welcome you all. I extend my warm welcome to Professor R.K. Goel, Professor of Pharmacology, former Dean Faculty of Medicine and Head Department of Pharmaceutical Sciences and Drug Research, Punjabi University, Patiala. I extend my warm welcome to Dr. Damanpreet Singh, Senior Scientist and Assistant Professor in Biological Sciences, CSIR, IHBT, Palampur, and Dr. Maninder Karan, Professor in Pharmacognosy, UIPS, Punjab University, Chandigarh. So I cherish the auspicious presence of all the delegates and faculty members. So I request Dr. Satwinder, Principal, GHG Khalsa College of Pharmacy, to kindly deliver welcome address. Please, ma'am.
A very warm welcome and a very good morning to all the delegates and to the speakers of today and the dignitaries. I would like to welcome you all to the second day of Faculty Development Program, exploring multidisciplinary avenues in pharmaceutical education and research that we are organizing from 8th to 20th August 2022. Yesterday's sessions were very successful and the topics covered were Ayurveda as well as the stability of natural products. Today, I am privileged to get this opportunity to welcome Professor R.K. Goyal, Director IQAC, Department of Pharmaceutical Sciences and Drug Research, Punjabi University, Patiala. A very warm welcome to you, sir, on behalf of GHG Khalsa College of Pharmacy and on my own behalf. Then next we have in technical session 1, I am happy to welcome Dr. Damanpreet Singh, Senior Scientist, IHBT Palampur. You are very welcome, Dr. Damanpreet. We are happy to have both of you in today's session. I'm happy, it's a privilege. This is an opportunity for me to welcome our very own Professor V.K. Kapoor. We are happy and honored to be associated with him. He is Professor Adjunct GHG Khalsa College of Pharmacy, Guru Sir Sadhar. Sir is always a motivation, and hearing few words from him is always an honor for us. You are welcome. I welcome you on behalf of GHG Khalsa College of Pharmacy, as well as on my own behalf. Then technical session 2, I welcome Professor Maninder Karan. She is my revered teacher, a very respected teacher. I have been her student. You are welcome, ma'am. Professor Maninder Karan, she is from University Institute of Pharmaceutical Sciences, Punjab University, Chandigarh. You are welcome, ma'am. And I also welcome Dr. Gulshan, President, APTI, Punjab State Branch. With his support, we are able to collaborate this FDP with Women Forum, APTI, Punjab State Branch. I wish you all a very good day, and I hope you will enjoy the lectures and gain the knowledge that is being shared by our speakers, and the purpose of this very FDP is served. A very warm welcome and wish you a good day and a successful event to the organizers of our team. Thank you so much. Over to you, Dr. Anuja.
Thank you, ma'am. Thanks a lot. So we have with us Professor R.K. Goyal as guest of honor. So Professor R.K. Goyal is working as professor in Department of Pharmaceutical Sciences and Drug Research, Punjabi University, Patiala. Professor Goyal has administrative experiences as Dean Faculty of Pharmaceutical Sciences, IKG PTU, Kapurthala, Director IQAC, Punjabi University, Patiala, former Dean Faculty of Medicine and Head Department of Pharmaceutical Sciences and Drug Research, Punjabi University, Patiala. He is having 26 years of research and teaching experience. His area of research includes neurobiology of comorbidities of epilepsy, pharmacogenomics of hypertension, and computer-aided drug delivery discovery from medicinal plants. Professor Goyal has guided 44 M.Pharmacy and 11 PhD research scholars, and 2 PhD theses are now under his guidance. He has 92 paper publications to his credit with highest impact factor 11.5. He is a member of various professional bodies. He fulfills various administrative responsibilities as Project Review Committee, member to Government of Italy, South Africa, UAE, India, as an expert in NAC, AICTE, Pharmacy Council of India, PTU, etc. He has 11 research projects granted to his credit, from which 3 are international Indo-Russian projects. Total funded amount 8 crores. He has delivered 40 plus number of invited talks, from which many are delivered in US, Russia, and Canada. He is a reviewer to many journals like Springer, Elsevier, Hindawi, LWW, Ville, Medno, etc. So it's my privilege to invite Professor Goyal to deliver a formal address. Please, sir.
Very good morning. Am I audible to all of you?
Yes, sir.
So first of all, I congratulate the team of GHG Khalsa College of Pharmacy for organizing such a nice FDP for young energetic faculty. This is important to motivate and say perpetuate development of teachers will be through these sort of programs. These programs are having, like in this one particularly, they are talking about exploration of multidisciplinary avenues for pharmaceutical education and research. So this is one of the component of conducting research, that is resourcefulness. How much resourceful you are, that will depend on how much you explore to produce new knowledge and to deliver that knowledge to the students as teachers. So there are many different session tracks I've seen in this FDP. Some are related to Hubbard development, some are related to drug discovery, some are related to the formulation development and other things. So I hope the speakers of these sessions will be talking about what is recently developed, what is recent knowledge in these areas, where we can update the knowledge of young faculty so that they can either take this as a lesson for imparting knowledge to the students at first hand in the theory part or in the practical exercises. Secondly, it should add to their what we say acumen so that they can inspire and stimulate the young faculty to do research in those areas which are new and which demand more attention, and they are having more promising outcomes for the society. With these words, I again wish best of luck. And one more thing, Damanpreet Singh is there as a speaker. I hope that he will be delivering excellent talk, and so you will be quite benefited by his words and his knowledge. Thank you very much to the organizing team again, and I'll also like to listen to him, but I will be having my video off. I have another meeting going on. So I'm sorry, Daman, so I will not be able to attend with video, so I'll be attending without video.
Thank you, sir. Thank you very much. Sir, your name is enough. Your name displaying on the screen is more than enough for me.
Oh, thank you very much.
It is always pleasure to have share the dice with you, sir. It is my, I say I am fortunate to have sharing a dice with you.
Thank you very much.
Thank you, sir. Thanks a lot for your kind words. So we have with us Dr. Damanpreet Singh, Senior Scientist, CSIR, IHPT, Palampur. So Dr. Damanpreet Singh did M.Pharm in Pharmacology as a specialization from Guru Nanak Dev University, Amritsar. After that, he completed his PhD in the area of pharmacology from Punjabi University and joined as an assistant professor at the Department of Pharmaceutical Sciences and Drug Research at the same university. He subsequently joined as a scientist at CSIR Institute of Himalayan Bioresource Technology, Palampur. Presently, he is working as a senior scientist in the same institute. He was a visiting scientist at NRICM, Tepai, Ministry of Health and Welfare, Taiwan. His work has been recognized by several awards, notably PC Dandiya Award, Dr. Hardyal Award, and Saroj V.N. Sharma Award by the Indian Pharmacological Society. He was the co-nodal for the nutraceuticals and nutritionals mission of the CSIR New Delhi. He also received the Early Career Research Award grant by SERV DST New Delhi. He is a member of the Indian Pharmacological Society, Indian Academy of Neuroscience, American Academy of Neurology, and many more. He is credited for establishment of zebrafish research facility at the CSIR IHBT Palampur. His major research area is epileptology. His research group is actively involved in understanding the neuropharmacological behavior of natural products. His research group is presently working on the development of natural product-based therapy for the management of epilepsy. He has published several articles in international journals of repute and filed patents. He is an editorial board member and a regular reviewer of several international journals. So I request Dr. Daman to deliver his talk, and his topic of discussion is integrative multiomics network approaches for target identification in chronic non-communicable disease, a special reference to epilepsy. Please, sir.
Thank you, Dr. Anuja, for a detailed introduction. So, first of all, most respected Goel sir, Principal ma'am, Satwinder ma'am, and all my colleagues attending this session. So, first of all, I thank the organizer for inviting me to interact with you all during this time of COVID lockdown. We still say that a lot of labs still are in the phase of lockdown. They are not operating as they were earlier. So, thank you very much. So, as far as my topic is concerned, Dr. Anuja has given a very polished title, but basically the name is big, but the thing is very small and simple and important. So, if you permit, can I share my presentation?
Yes, sir, yes.
Haji.
So it's visible, Dr. Anuja?
This is visible, sir.
So it's in full screen mode, I hope.
Yes, yes, it's on full screen mode.
Okay, okay. Thank you. So, as already described by Dr. Anuja, my title of this presentation is Integrative Multiomics Network Approach for Target Identification in Chronic Non-Communicable Diseases, with a special reference to epilepsy. So before I start my talk, I just want to give an overview of our institute. So this is one of the constituent lab of Council of Scientific and Industrial Research. So this is just an photograph. I think a majority of you have already visited this institute. So first of all, it is our entrance of our institute. And secondly, you can see the lab situated in the foothills of Dholadhar mountains, covered with snow. And third picture is of tea gardens, for which this place is famous for. So if I just give a brief overview of the institute, it is one of the constituent laboratory of CSIR, that is an autonomous body of Ministry of Science and Technology, and Government of India. It has 38 national laboratories working in different fields of science, starting from road to sky, road development, building development, biology, plant sciences, chemical sciences, aerospace, and all the avenues of science has been touched by CSIR. It has 39 outreach centers, 3 innovation complexes, and 5 units. And the focus of IHBT is to develop technology in a sustainable manner to cater the need of Indian population. So coming to my topics, it is omics. So when we first hear about this term omics, it indicates that it might be a complex thing. But if we see the basic of this omics, it is very simple. It is just a meta-analysis of all the small particle. If we say at organism level, it is a study of the complete genes. If we say in the plants, it is a complete study of the whole metabolome. So if we say it is a collective characterization and quantification of pools of biological molecules. And if I am saying biological molecules, the basic unit is gene. And the complete set of quantification of gene, we say it's a genomics. So I'll explain basically in my subsequent slide what exactly I am saying. So next, it can also be for chemicals, like we are extracting something from plant. It has an extract. And nowadays what we used to do, we just characterize 1 or 2 extracts. But the trend is to go for metabolomics. You just go for the profiling of each and every molecule of that particular extract and then have a chemical library. And that development of that library, it is the metabolome of the complete set of that extract. And if we say about genes, the field it is genomics, and it became important in the year of 1990s. If we say it is just 40 years old. And with the advent of more scientific techniques, the term genomic, it was extended to metabolomics when we say it is the study of plants. And nowadays the concept is to study the lipids. Like people are suffering from cardiovascular diseases, and the main culprit is the lipids. And now it is analysis of the complete lipids of our body. Like we know it is a good fat, bad fat, and there are some neutralizing fat, and the complete set of the complete study of these lipids, the condition become lipidomics. And the same now the study of food, each and every aspect of food at molecular level, it gives rise to the term that is foodomics. And in the same way, it is metabolomics, it is a metagenomics, it is a proteomics when the studies of complete protein. Actually, what we do in our lab, we just select a particular gene and we target on that. But exactly if we say it is not a single gene, it is a network of genes that form a pathway. That pathway develop, it alter the protein expression, and an alteration of this protein alteration, it results in the pathogenesis of a disease. And if we say about in case of medical sciences. So if we say just what is its approach, it is a simply it is a combination of molecular biology, computers, and internet. As I have already said that the field of this genomics, it is highlighted in past 20, 30, 40 years, because all these three things it has established in past 30, 40 years. Basically, what we do, we just isolate a particular tissue. For example, I am interested in a cardiac tissue, or for example, I am interested in a renal tissue. A person is suffering from a renal disease. So just isolate a kidney, isolate the whole RNA, convert it into cDNA, and then using a particular instrument, we just analyze the whole set of genes. That what type of the genes that have been overexpressed and what are the genes that have been underexpressed. So it is a technique of molecular biology. And the next phase, the data that we have collected of this expression study, we feed it to the computer using different software. The computer, it make a correlation that gene 1, it is interacting with gene 2, gene 2 is interacting with gene 3, and then it form a network. And this network is then thrown into the different server by the means of this internet. And then internet, it make a network and it comes out with that this is a particular pathway that has been altered in this particular condition. And now you have a pathway, and then you define a drug, you define a molecule for which you are interested in. Fine. So this is the whole idea of this. So why it is important? Why we need to have this genomics approach for nowadays? Because all the therapies that we are using till now, these are generally based on, we say, symptomatic relief, like person suffering from hypertension. We know the hypertension, it is when the pressure inside the vessel it get increased. And our main focus is to reduce that pressure either using diuretic, remove the excess of water from the body so that the pressure inside the wall it get reduced, or dilate the vessels so that the pressure get reduced. But all these mechanisms, these are just a compensatory mechanism. Reducing the water inside the vessel, it is a compensatory mechanism. Dilating the vessel, it is a compensatory mechanism. We don't know why there is particularly increase in pressure, whether it is some molecules that are involved, there are genes somewhere that are involved that are producing some abnormal proteins that is altering the pathogenesis. What exactly it is? So it is important. I'll just give you an example of diabetes, that why it is important and why there is now rediscovery of pathogenesis of these diseases, because we know diabetes is very much common. That's why I have taken this example. So we say diabetes, its term was originated in 1675 by Thomas Wills. In 1675, we say around 500 to 600 back, 500, 600 years back, you are aware what is diabetes. And if we say the therapy earlier, we are just more focus was on insulin. And insulin was established in 1921. We say after around 300 years back, after 300 years that the disease was originated. The disease was originated 1600. First therapy, it was originated primarily therapy 1921. We came to know about the insulin by Frederick. He was later on given the Nobel Prize in 1923. And the oral hypoglycemic, it was established, first was this metformin 1900, then it was oral hypoglycemic under sulfonylureas in 1942. Means again after 300 years back. So what they were doing, they were just reducing the level of glucose. But still we don't know what is the exact mechanism of this disease. Now we are revisiting. Like, these are some of the recent study of omics, where we are still understanding what is the pathogenesis of diabetes. Means the disease was originated 600 years back, but still we don't know the pathogenesis. This is the beauty of this omics technique, that we are now understanding the genetic makeup, genetic alteration, what is leading to a particular disease. This is particularly in the context of diabetes. 2020, transcriptome sequence analysis of peripheral blood in type 2 diabetes, because the level of glucose it get increased in the blood. So what is the effect of that glucose and that particular cellular component of the blood? It was being carried out in 2020. So you can see after 600 years that with the disease was originated, we have first line, second line, in first generation, second generation, now third generation of anti-diabetic agent, but still we are understanding the pathogenesis. But we should thank to this omics technique that we are able to understand the exact pathogenesis, what is happening. So similarly, it is the next study, it is a meta-analysis that was carried in 2021. It is just a meta-analysis of 3-4 years back, the whole transcriptome analysis of the pancreas, the organ where we say the main problem of diabetes is there. Again in 2021, means if in 2-3 years we are now just trying to understand the diabetes, a well-known disease. So now I will just try to explain that how we have applied this thing to a particular condition for which we are very the information is very less, because the condition is like that we cannot get the patient, we cannot get the tissue that is required. So I'm talking about a particular condition that is related to epilepsy, not particularly epilepsy, it is an epilepsy associated condition. So before I start, I just want to give a background what and how we have initiated this work. So one of my students, Arindam, he now has completed his PhD and now working as a postdoc. Now he has shifted to Baylor College of Pharmacy in US. And he was working on particular molecule that was this MMF, that was mycophenolate mofetil. He was interested to understand its effect in epilepsy. So to carry out this particular histopathology, you can see the sections of neuronal damage and this mossy fiber sprouting. To carry out this particular technique, one has to give a cardiac transfusion. That the whole blood has to be removed. We give an injection into the heart, and for which the whole blood is then removed from the auricle, and then we replace that blood with a particular staining agent so that we can have in situ staining. So while he was doing his work, he used to come to me that, sir, I am trying, but it is difficult to give injection in normal animal, but it is easy to give an injection in an epileptic animal. It was quite interesting, because we think the thing is normalized with a normal, but it is complex when it is a disease. The thing was different. He said that, sir, it is very easy to give injection in epileptic animal, and it is difficult to give an injection in a normal animal. So it was quite interesting, since we were not interested in this. Our focus was in brain, but still we have to give and we have to use the methodology. That's why I just went to the lab and I said that just remove the heart from the both animals, normal as well as epileptic. So you can see what we observed. The first one was the normal heart and second was the epileptic heart. It was quite interesting. The size was more. So because of more size, he was able to easily locate the ventricular region, because there was dilation in the ventricle. So he was easily able to give the injection in the ventricle and remove the whole blood from the auricle. The thing was, the heart was not more normal, it was dilated. And it is easy to give injection in the dilated region rather than to have a rigid region. So it was quite interesting. Then we initiated this study. And first we tried to establish, is there any relationship between epilepsy and heart and whatever it is, because we are seeing the pathogenesis in front of our eye. Then we have replaced this experiment. Now with not a focus on epilepsy, but with a focus on heart. We use the epileptic animal, and during the process of epileptogenesis, we have used lithium pilocarpine model here. Basically, what we do in this model, we just damage the brain initially by inducing the status epilepticus, so that there is an epileptic foci inside the brain, and then we allow the animal to survive for around 2 to 3 months. And during this process of 2 to 3 months, there is an alteration in the brain networks. And ultimately, there is appearance of spontaneous recurrent seizures. Automatically, the animal starts showing seizures, the same condition that we observe in case of epilepsy. In the clinical, we say it resembles the temporal lobe epilepsy condition of humans. So what we observed, and the findings were very interesting. When we weigh the heart of epileptic animals, it was more as compared to the normal heart. It indicated that there is something abnormality. There is something, either there is a deposition of fluid, or it is high fibrosis, it is anemia. Something is there that is increasing the heart rate. And then we carried out the non-invasive blood pressure monitoring of the epileptic animal during the whole phase of 2 to 3 months. At the basal level, we say the change in the blood pressure was 0, which was normal. But after we have induced the damage inside the brain and the animal, it remained in the latent phase. Latent phase when there is no appearance of epileptic seizure. There was fall in blood pressure. The pressure, it reduced. And when the epilepsy progressed, the pressure increased and it increased. It increased after 2 months, it got more increased after 3 months. And after 3 months, we isolated the heart. And if we understood this ECG electrocardiography, we observed that the QTC interval it get increased, that it indicated there was some alteration. And this alteration, it mimicked the dilated cardiomyopathy of humans. It was a good finding. Then we find out that whether there is a relationship between the epilepsy, heart, and cardiovascular system. So what the literature said that epilepsy is associated with the higher risk of mortality as compared to the normal population. And the risk is 8% higher. And recurrent seizures that alter the neuronal membrane function that results in irregular transmission. Okay. We just simply say that in normal condition, my brain is normal. And the person when it become epileptic, the neuronal activity get increased. Their firing get increased, the depolarization become increased, and because of this increased depolarization, it sends the signal to the muscular tissue, and there is an abnormal movement during the epilepsy. This means that the activity of the neuron get increased even at the resting state, and the activity, if it is increased, the neuron needs energy. It needs an oxygen, and both of these things it has to be compensated by the blood, and the blood has to be pumped by the heart. Means if there is abnormality in the brain, the normality of the heart it automatically gets disturbed. The heart start pumping at more pace. The vessel it get more dilated initially, and there is alteration inside the brain. And this was the whole idea that this was the whole finding that why there was this alteration inside the heart. And when we observe the literature, there was not much more information available in this condition. But this thing was sure that there is a sudden death in epileptic patient. The patient died because of unknown reason. Epileptic patients sometimes they die, and later on it is discovered that heart attack ho gaya. It was a cardiac arrest. But basically, it is not a cardiac arrest. It is a sudden unexpected death because of epilepsy. And the literature that said that is available, it shows that there is an excessive activation of the neuron that automatically increases the sympathetic activation also. Although epilepsy, it is a central nervous system disorder, but its activation, it increases the sympathetic outflow. And the sympathetic nerve, they give signal to the heart because of which it starts pumping at a greater pace. Initially, it compensates, and at longer duration, it starts showing abnormality. And because of that abnormality, it results in the death. So this thing was clear that there is a sympathetic activation that was in line with the sympathetic activation that we observed, that there was increase in blood pressure and prolonged QTC. This thing was clear, but what exactly it is leading to further, what are the molecular changes, it was not clear. Then we just carried out the histology of this heart, and what we observed that the cardiomyocyte thickness, because it was a dilated cardiomyopathy, the thickness of cardiac tissue, the cardiac myocardial, it was more. It's obvious because the heart is exercising a lot. It is doing more work. The thickness was in line. Then there was fibrosis. It was quite interesting that it is fibrotic. It is a fibrotic lesion deposition. It is a collagen deposition inside the heart. That because of what was the reason of this? Then we have just carried out some supportive Western blot analysis, and we found that this TGF, S6, phospho-S6, HIF, all these protein level it was increased. These were just pick. We have just picked this protein based upon the pathogenic finding that we have observed. We don't have any idea what is the molecular changes that is leading to increase in TGF, S6, phospho-S6, HIF. It was not clear. We just, however, we make an assumption, and we just concluded the study that this is because of this pathway. But still, the thing was not clear. Then we initiated further. Then we go with the omics study, because being a pharmacologist, I have just a limit that I just have this much knowledge, what I can do. Then we have discussed, our group, we have discussed with the bioinformatics person that how we can identify the network that is leading to the damage of this particular condition. Then they suggested that let's go for the complete transcriptome. Complete whole transcriptome as well as proteome analysis of the heart. It was a big study that we have initiated. We have used the same model, lithium pilocarpine rat model of spontaneous recurrent seizure. But in this case, after isolating the heart, we won't proceed it for histology. We have proceeded it for RNA sequencing. We use the Illumina Novasec 6000 system. These are the limited systems that are available in our country. And ISBT, one of the lab that is having this system. So we then processed our heart for this RNA sequencing. Then we carried out whole transcriptome analysis just to understand what are the in the whole genome of this heart cardiac tissue of the epileptic rat. What are the genes that are overexpressed and what are the genes that are underexpressed? And then after getting the information from the sequencing, then we carried out differential gene expression. Differential simply just say that, for example, 2000 genes, they were overexpressed, 4000 genes, they were underexpressed, and how this differential expression is taking place. Then we carried out gene set enrichment and pathway analysis. Then we pick the gene and make a pathway based upon the databases that are available. And after having the set of genes, gene-based pathway, then we carried out protein-protein interaction. For this, we use this protein isolation, and then we carried out LCMS MS-based proteomics. For this, we use Qt of LCMS system. And to establish the findings of this proteomics and transcriptome analysis, we use Western blotting for protein expression study. We use quantitative real-time PCR to validate the findings of this transcriptome analysis at gene level. And this is a whole, we say, this is a heat map protein. So we say this epi-G, is epi-G, it indicates it is an epileptic group. NAV-G, it indicates the normal group. Fine. So here the red represents the relative increase in the abundance of a particular gene. Similarly, we have blue and we have white. So you can clearly see that the expression, it has been altered in epileptic animals compared to the normal animals. So this gives an idea that there is variation. The things are not just that what we have picked. The thing is something else. The story is something else. Then we made a network of all these things. So there is a complete network analysis, and by the study of this whole network analysis, we came to know that the pathways that are related to vascular development, positive regulation of cell death, neuron projection, morphogenesis, that these are the pathways that play a role, that are playing something role. All these pathways, these are modulated somewhere during the whole process of this cardiomyopathy that is happening in epilepsy. So then after we carried out network analysis. So you can see there are two types of hubs. Hub is simply what we say, these are the part of that particular pathway, that if we remove this particular target, the whole pathway will disrupt. So mean these are the important things. Because if we say in a particular pathway, like we say in COX-2 pathway that is involved in pain. So there is activation of COX-2, then it results in number of activation of prostaglandin. But for pain, there is one or two prostaglandins that are involved. So we say if we are interested in pain, we need not to follow all the other pathway things. Basically, the prostaglandins of my interest, if we remove from that pathway, the whole pathway gets disturbed. So these are just those, we are terming those two things as hubs. So these are intramodular and intermodular, inside the pathway, or it is making a network with the two pathways. So these are the targets that we have identified. If we can remove these and we can target any one of these, the whole pathway of this damage get disrupted. So after that, we carried out the protein-protein interaction. See, sometimes it happens. It is not likewise that if the particular gene is expressing, it will definitely translate into the protein. It is not every time this. Sometimes number of genes they get, they show expression, but they won't get translated into the protein. There are several other pathways. So to find out that whether the gene is correlating with a particular protein, if I say, for example, the gene that is responsible for the activation of COX-2 is being expressed at transcription level. It's not sure that it will definitely result in the activation of COX-2. It will activate COX-2 level, because For that, it has to get translated. And sometimes it is not as it is. Just to have an overlap that whether the gene has been activated, and it will definitely result in the activation of protein, we carried out DEG and DEP correlation. DEG, it was your simply differentially expressed genes and differentially expressed protein, and we merge. We get 1,137 genes that were activated, 633 proteins that were overexpressed in this condition. And when we overlapped it, there was only 9. We get 9 overlapping. That 9 genes were just translating into the protein, and these were of our interest. And for this, we have carried out a cellular pathway study, biological processes study, and then we made a heat map protein, the whole using BLAST2G system. It is just a gene ontology annotation study. So just to see what is happening at transcriptome level, among those 19, this blue, it indicates those genes that are activated at gene level, at transcriptome level. And for proteome, these were the green. And pink, this is the, we say it is the, these are those proteins that have been expressed into protein. Means these were of our interest. And then we carried out its validation using qRT-PCR analysis. And the things were in line with the results of transcriptome and proteome. So you can see the level of STAT3, FOX, MAPK, MYCM, SRC, mTOR, these all get increased. Just with the SRC, it get reduced. Just all the genes. I mean, this was just a contrast in this difference from the result of proteome and transcriptome, that SRC level it get reduced. And to justify this, we then carried out Western blot analysis for this particularly protein expression study. So here it was very interesting that STAT3, it was the gene that was reduced in both the things. Generally, what happened, the native at native level, the level of particular protein is normalized, but it gets its phosphorylated form, it gets increased. Like you see in case of mTOR. At normally means the gene has expressed the mTOR, and how much that mTOR has been phosphorylated, it is different thing. So in mTOR at normal level there was no change, but activated level it got increased. The same was with beta-catenin, but the thing with the STAT3 it was different. That somehow it has justified what we observed in the gene expression study. So the whole this study concluded that there is a specific role of mTOR pathway. If we can target that, we can avoid both epilepsy as well as our cardiac injury. So this work was whole completed by Dr. Supriya. Now she is a postdoc fellow at the University of Virginia. So this particular work, it was published in Epilepsia. It is one of the prominent journal of International League Against Epilepsy. So next thing come, we want to validate that this whole work, that there was alteration at proteomic level, it was alteration in transcriptomic level, but whether practically if we inhibit that particular pathway, it will result in the curation of disease. Like for example, we observed that activation of mTOR is leading to development of this disease, and whether practically it is happening like this or not. For that, there is a single option that we use an mTOR inhibitor. We just inhibit that pathway, and if the disease progression has been stopped, it indicates that our finding was verified. But the problem was that the inhibitor, because these all inhibitors, these are the trial drugs, the cost is very high. So if I want to use that particular inhibitor for rat study, the cost was around 8 crore of that particular molecule. Even I say it was around 10 times more than the total cost of this project. So alternatively, we don't have any other option. We have to repeat this study in case of small animals. For this, we first use, we think to use zebrafish. But the problem with the zebrafish is that it has a good regeneration capacity. Acute models, they are well established for zebrafish, where we easily give PT, pentylene tetrazool, or any chemoconvulsant, it shows seizures. But this condition, this epilepsy-associated cardiac injury, it is a chronic condition where the damage has to be prolonged. For that, first we developed this model. We developed this new model for zebrafish, kindling model, that is a chronic model, and then we established that whether it is leading to cardiac injury or not. So for this, we have used two different approaches. One was more successful, other was less successful. And for this validation, we use sodium valproate acid. Sodium valproate. It is a clinically used anti-epileptic Our aim was to just see that whether it is inhibiting the seizures, if we are inducing like this or not, because this sodium valproic acid, it is well established in chronic models of rodent. So we use that same molecule for fish, and we observed that yes, this model can be useful. It was published in Journal of Neuroscience Methods, and then we use the same model for the same to complete our initial study, where we have observed that mTOR inhibition can lead to protection against seizure. So here we use the mTOR inhibitor, that was rapamycin. We induce the seizure by the same model I have just explained in my previous slide. But the problem was that rapamycin was not soluble in water, and we only have an option that we can give our drug to the fish in the system water. For this, we have to inject the drug to fish. So this is the method what we use, and this is the place from where we have isolated the heart. And what we observed, that the story of our STAT3, it was in line with the wet lab analysis. There was activation of mTOR pathway, and the mTOR was inhibited when we give the rapamycin, and ultimately the heart was intact. It was preventing the heart damage. So after that, we have further elaborated our study. Now we are in the process of identifying the molecules of natural region where we can use those molecules as mTOR inhibitor for the management of this condition. And there we are using the metabolomic techniques. So I think I have still 5 to 10 minutes left just for discussion. So this is my group. 2 students already, those who have worked for this project, they have already completed their PhDs, and all these are working now in the different areas, major focus on epilepsy. So thank you. So this is my contact if anybody want to note down. And I will be happy to discuss anything related to my work. And now I will love to have some queries, anybody.
Thank you, sir. Thank you. It was a really very informative session. You have discussed genomics, omics, identification in the target identification, proteomes analysis of the cardiac tissue, as well as the JEPTA fish model. If anyone having any kind of query, he or she can drop their message in the chat box. We will unmute you. Anyone? I think there is a no query. Okay, so there is no query.
No issue.
So it's time to felicitate Dr. Daman. Kindly accept our token of gratitude. Thank you very much, sir.
Thank you, ma'am. Thank you.
Thank you, sir.
Thank you, ma'am. I have kept 10 minutes for discussion. That's why I have completed my presentation 50 minutes. No issue, no problem. If anybody have a personal, I can definitely respond.
The session is open for the queries. Kindly drop your message. Anyone, if you are having any kind of query, you can drop your message in the chat box. Your session was so interesting. That's why everything was clear.
Okay, ma'am. Thank you, sir. Thank you, sir, for sparing time.
Okay, sir. Thank you.
Okay, ma'am.
Thank you, sir.
We have with us.
Now we are having with us Professor Maninder Khan. She is presently working as professor of pharmacognosy, University Institute of Pharmaceutical Sciences, Punjab University, Chandigarh. She has more than 25 years of teaching and research experience. She has guided 8 doctorate. 4 are currently pursuing PhD under her guidance, as well as 33 postgraduates. She has authored more than 115 research papers in the reputed peer-reviewed international as well as national journals, and has widely delivered lectures on the various topics related to pharmaceutical sciences. She has also authored and co-authored several book chapters and books, and she is also working as a reviewer for the reputed professional journals. Dr. Maninder has 56 monographs to her credit, of which 26 are pharmacopoeial monographs. She has filed 9 patents. She has granted 3 patents and transferred 1 technology. 2 more technologies are already ready to be licensed. She is an editor of Pharmacos as institutional journal and has completed 4 projects of Ayurvedic Pharmacopoeia of India and ICMR, and one of the most reputed outcome is formation of the Derby gel as the proprietary medicine. Dr. Maninder is currently monitoring an industrial startup project as a coordinator cum consultant. She was former expert member of the Unani Pharmacopoeia Committee, Ministry of Health and Family Welfare, Government of India, New Delhi. She is also IQAC cell coordinator at University Institute of Pharmaceutical Sciences, Punjab University, Chandigarh.
I think ma'am is busy in meeting.
I think Maninder ma'am is busy in meeting. We can resume the session after some time,
So 15.
15 minutes.
Actually, Maninder ma'am is busy in some meeting, in some official meeting. So we are having Dr. Kapoor with us. So we will go with the lecture of Dr. Kapoor. So we are privileged to have Professor V.K. Kapoor with us. Professor Adjunct from GHG Khalsa College of Pharmacy, Guru Sir Siddhar, amongst us. He has experience of approximately 45 years in medicinal and pharmaceutical chemistry and chemistry of natural products. Professor Kapoor has received various awards and honors as Shri Bhojraj Panchpul Lifetime Achievement Award in 2011 from APTI, Shiksha Bharati Puraskar in 2011 by All India Achievers Foundation, New Delhi, Professor G.P. Srivastava Memorial Award Fellowship from Indian Pharmaceutical Association, Commonwealth Academic Staff Fellowship from Association of Commonwealth Universities, Senior Research Fellowship of UGC, and also got distinction in chemistry in the intermediate examination in 1957. He is a life member of Indian Pharmaceutical Association, life member of APTI, life member of Indian Society of Technical Education, Scholars India. Dr. Kapoor has a large number of professional and academic recognitions and served as a speaker and evaluator of a huge number of conferences, workshops, and seminars. He started his career as pharmacognosist from Medical College, Amritsar, then served as Secretary Chairman, Dean in UIPS, Punjab University, Chandigarh, Dean in Punjab Technical University, Principal and Director in GHG Khalsa College of Pharmacy, and presently working as a Professor Adjunct in GHG Khalsa College of Pharmacy. Professor Kapoor has more than 140 publications, which includes 7 books, 15 book chapters, 29 review papers, 46 original research papers, 16 papers on pharmaceutical education, 12 journal scientific papers, 15 articles of professional interest, and 1 directory to his credit. Over 25 papers are presented at various national and international conferences by Professor Kapoor. He has also one patent to his credit. So I invite Professor Kapoor to just give a formal address. Please, sir.
Am I audible, Dr. Anuja? Hello,
Yes, sir, you are audible. Welcome, sir.
thank you for giving me an opportunity.
Sir, is honored to have you.
So I'll have a detailed talk in some other session, but I'm very pleased to know that my own college, GHG Khalsa College of Pharmacy, is undertaking another path-breaking program, that is faculty development program, see, in which eminent speakers have been selected, and I am happy to interact with them online. Dr. Satvinder deserves a recognition, deserves a congratulation for being selected as the woman convener of APTI Punjab.
Thank you,
And-
sir. Thank you.
And Dr. Anuja and her team is very efficiently coordinating this whole program. You see, I had the honor of being associated with this college for a long time. I spent there 10 years of my life at the campus of GHG Khalsa College of Pharmacy. And in a way, I'm still attached with it. It's such a beautiful place, and it is a premier institute of pharmaceutical education and research in Punjab. It caters to the needs of not only the rural lives, but the students from far off places. They also come to take their career in pharmacy. It will be very educating program because the speakers which have been selected, they are expert in their own respective fields. And you see, the best hospital in the world is in the United States, in Baltimore. The founder of that hospital, William Osler, has said that the characteristic of taking medicine is the only feature which differentiates animal from man. The desire of taking medicine has been since the dawn of mankind, the dawn of humanity. When the medical system was not very well organized, in ancient times, the therapeutics or the removal of the diseases were undertaken by the holy men, which were called shamans, S-A-M-N-S, shamans. I mean, those were the persons who used to treat by the help of certain old medicines derived from plants, and some of the animal products they were also used. For example, for the treatment of upset of the, if the stomach is upset, they used to give earthworms rolled in honey. In the cases of tuberculosis, ox lung was used, and cow dung and moldy bread poultices were used for stopping infections. That was the state of affairs, but the start of proper treatment started from the Greek civilization. There were Greek physicians like Hippocrates, after which the oath of Hippocrates is there in all the medical colleges. The students admitted, they take the oath of Hippocrates. And recently, the Indian Medical Commission has recommended that the Hippocratic oath should be replaced by our Ayurvedic physician Charka and Shishruta. But it is taking time that when there will be total acceptance of this suggestion of Indian Medical Council, Commission, shifting from Hippocratic oath to the Charak oath. So Hippocrates is known as the father of medicine, and he was born 460 BC. And after that, the prominent name in the upliftment of the therapeutics was done by Dioscorides. Dioscorides was the person who produced the first Materia Medica, and it had a 5-volume Greek encyclopedia about herbal medicines and related medicinal substances. The Greek Materia Medica is the compilation of 600 plants, 25 animal products, and 90 minerals. You see, that was in the older times, but the modern medicine can be said to have begun in 1785, when William Withering propagated the use of foxglove, botanically digitalis purpurea, for the treatment of the cases of dropsy and heart block. What I want to emphasize is that in yesterday's lecture, Dr. Praveen Bansal from Faridkot delved on the importance of Ayurveda in medical system, and Dr. Bansal from Patiala also delved on importance of plants in the modern system of medicine. And only 2 days back, there was a big news in the local papers of Chandigarh that the director of PGI told that they are going to start the course of yoga and Ayurveda in their curriculum. What I mean to emphasize that plants have been the source of medicine right from the beginning. I mean, it is only the investigations of medicinal plants which gave you the drugs like morphine, ephedrine, quinine, atropine, etc. And later on, reserpine, vinblastine, vincristic, taxol, artemisinin were discovered, which changed the scenario of the treatment of a number of diseases. These drugs came only through the study of the secondary metabolites of natural products. Now, these natural products not only came as a drugs for the treatment of a number of diseases, like paclitaxel or Taxol was found useful in the treatment of cancer. Artemisinin is a substitute for synthetic anti-malarial drugs. Similarly, but the work of natural products, besides giving these wonderful molecules in therapeutics, they also serve in the propagation of synthetic medicinal chemistry. You see, morphine, if you take the example of morphine, which is a pentacyclic structure, but was found to have two side effects. That is, it produces drowsiness, depression of the central nervous system. If given in higher doses, it may lead to respiratory depression. And second undesirable property was the dependence liability, that is addiction. So medicinal chemists thought of modifying morphine to get a synthetic molecule as good as morphine in its analgesic action, but devoid of its dependence liability property. And they started with the simplification of the morphine molecule. If the participants can visualize the morphine, from the pentacyclic structure, they produce tetracyclic structure. They broke the oxide bridge, and it led to morphina. And that gives you another drug like race morphin or the levelomorphin, etc. A number of diseases were produced. And the greatest advantage was made when the simplification was further carried out in the form of 6, 7 benzomorphins, right? 6, 7 benzomorphins were the first kind of analgesic drugs which were devoid of some degree of addiction liability. Example is pentazocine, and further simplification led to the emergence of pethidine, meperidine, and ultimately simplification led to methadone. So morphine offered a molecule with the help of which, taking this molecule as a prototype, a number of synthetic drugs were developed and discovered by the medicinal chemists. So the natural molecule, besides its therapeutic actions, provided templates for the emergence of synthetic medicinal agents. Like atropine was the molecule on the basis of which a number of antispasmodic and anti-ulcer drugs were produced. right? Similarly, codeine was modified and taken as a molecule, maintaining the central core of 6-methoxyquinoline, and they produce 6 amino derivatives, synthetic derivatives like chlorotoluene and other semi-synthetic drugs. So what I mean to say, that plant research has been a basis of development of therapeutics, and there was a period of 1960s and 70s when the research in medicinal plants was undertaken by the School of Pharmacy and the School of Pure Chemistry throughout. And the negative part has been that they have been, the phytochemists, they have been isolating number of novel molecules. Their structural elucidation helped them to make the publications in international journals like Journal of Organic Chemistry, Journal of American Chemical Society. But the disadvantage was that those molecules which were isolated from plants were left as such. They were never subjected to any pharmacological activities. So we do not know, maybe more than 3,000 compounds were synthesized which were not novel, but they helped the chemists to make their career glorified by the publication they got from the investigation of plants. Have they kept the specimens of those substances which they discovered or isolated from the natural sources? Maybe another molecule of artemisinin, another molecule of drug like paclitaxel, another molecule of rezapine could have been discovered. That has been a very, saddening part of the research in pharmaceutical sciences. Even now, we have 45,000 species which are growing in various agroclimatic zones. And more than 12,000 of these 45,000 plants, 12,000 had been attributed by some medicinal properties. If you explore the folklore literature and go into ethnopharmacology, you will find that still there are 12,000 plants which have been attributed with medicinal properties. They are being used in folklore as a treatment of several diseases. But out of these 12,000 plants, only 12% have been investigated chemically and pharmacologically. There are still thousands of plants which are left undiscovered, unexplored chemically and biologically. So the pharmacy people unfortunately do not realize the potential of nature, the potential of biodiversity for which India is famous, to undertake the discovery and development of drugs of potential use. Secondly, in this respect, through this forum, the APTI, since we are all, in a process of pharmaceutical education, we are the creator of new syllabi I do not know why one of the discipline, pharmacology, has been ignored by and large by the pharmacy educational institutions or even by the highest body controlling the profession, Pharmacy Council of India. You see, if you go back in 80s, when I was in Punjab University, everybody used to opt for 3 courses. Pharmaceutics was there, pharmaceutical chemistry was there, and pharmacognosy was there. In all the 3 disciplines, the well-deserving students with higher percentage of marks in B.Pharm course, they used to go for pharmacognosy, chemistry, and pharmaceutical chemistry. Because at that time, even in pharmaceutics, the new advancement like novel drug delivery systems were not developed. So everybody was in the process of taking investigation of Indian medicine plants. Now at that time, I'm talking of from 80s onwards, there were 3 or 4 stalwarts in pharmacy education. I do not wish to name them, but they were at the helm of affairs, both in designing the pharmacy curriculum, and they had a hold on Pharmacy Council of India. I do not know, still do not know that why they developed a sort of prejudice, a preconceived opinion that is not based on reasons or actual experience, that a dislike for pharmacognosy was propagated. Those were the persons who were obsessed with research instead of teaching. And they said the pharmacognosy curriculum does not offer anything in the area of research because they are doing macroscopy and microscopy, the study of families, plant family, this and that, without realizing that they have their own importance. Now, in the British pharmacopoeia, in the United States pharmacopoeia, and in Indian pharmacopoeia, the study of powder drug is essential and forms a part of the monograph of a useful medicinal plants. Like berberis is there, aconite is there. But the saddest part has been that those who were engaged in pharmacognosy teaching, they did not somehow shifted their attention from microscopy and macroscopy to phytochemical studies. They thought that chemical investigation is very tedious work, and the study of IR, NMR, mass spectroscopy, they found it very difficult, with the result that pharmacognosy stayed where it was. But there are so many examples of the contribution of plants in the development of pharmaceutical research. So I wish to emphasize that it is high time that this subject should be revived. And I urge all the stalwarts of APTI to press upon the Pharmacy Council of India not to neglect the pharmacognosy curriculum, there is a lot of scope of investigating new drugs, new molecules from 70% of the existing flora for the exploration of new medicinal substance, new molecules with novel structure, new molecules with novel therapeutic activity, which will form the lead molecules for the development of medicinal chemistry. I think sooner we recognize this thing, the better it will be for the profession. Really, if you explore, pharmacology has been called as the mother of pharmacy because every system of medicine was based on the plants. I do not mean to downgrade the other disciplines like pharmaceutics. It has its own importance, or pharmaceutical chemistry, which deals with new analytical methods for detecting the impurities, or pharmacology, which deals with the toxicity studies, which are very important. But in pharmacology also, I'm sorry to point out that pharmacologists, they have a sort of superiority complex. They want to take up the things like receptorology, like molecular fundamentals of drug actions, but they still feel shy of investigating the plant extracts. It is a very sad affair in pharmacy that pharmacologists who are otherwise doing very good work, but they shy when they are asked to undertake the investigation of a plant extract to find out some novel activity. To my friends, I do not mean by this expression to underdown other disciplines, but I am speaking on the improvement or the recognition of a discipline, pharmacology, which has been left out, and it has been, going to be abolished out of the curriculum. There are a number of institutions, pharmacy institutions, where M.Pharm in pharmacology has been completely washed out. You see, we should recognize our heritage. We should recognize the contribution of Charak, the contribution of Sushruta in the advancement of medical systems, in the advancement of therapeutics. It is deplorable that Ayurveda is not taken up by the medical colleges of India, but in American countries, there are universities where in the curriculum of MBBS, an alternative system of medicine is taught. Maybe it is Ayurvedic system of medicine, or the Chinese system of medicine, or the Egyptian system of medicine. These are the fundamentals of medical sciences, which have not been ignored. In Germany, there are more than 14 universities where Ayurveda is taught. The Sanskrit is the subject in many of the German universities, and you might have heard that our older literature like Vedas, they have been translated into their own German language in those universities. So we should not feel ashamed to value our own heritage. This is what I mean to suggest by this short address to my fellow colleagues, to my fellow teachers who are listening to me. You see, even government is propagating, government is recommending that inclusion of Ayurvedic system of medicine to be taught in medical curriculum. The Department of Ayush has been upgraded to the level of ministry. You have a union minister of Ayush. So, but why pharmacy institutions, they are ignoring this important facet of drug discovery? It is not understandable to me. I feel passionate because the plants have always been, my favorites. You see, I tell you a personal experience of mine. When I was in my high school, my parents left me to stay with my grandmother, right? And they had been transferred to some other place. So I was left with my grandmother, who was a widowed old lady, and she used to carry out various religious rituals. She had a Thakur Dwara where she used to give a wash to the deities and idols, apply them the chandan, apply them the purified water like that. And she used to argue, request me कि विजय मुझे तू थोड़े से फूल ला दिया कर, मैं भगवान के चरणों में फूल चढ़ा दिया करूंगी. But I had no access to flowers. There was a Jubilee garden where I used to go and pick up the flowers, and several times the malis there, they caught me and reprimanded me. So what I did, that instead of going there and plucking the flowers, I plucked a panili, a seedling of the flowering plant from the botanical garden. I stole it and I brought it at home, and there was a shallow pan which I filled with sand and planted that plant. First of all, I was very skeptical about whether the plant will survive or not. So next day I went to see the plant. It had survived. It had not been khatam nahi hua, hara ka hara raha. I was very happy. Then again, I was watering it. I saw that the plant is growing. I felt very happy. A day came when the plant gave me a bud. There was a small bud. I was again very happy. And next time when I went to see the plant, the bud, a small flower bud, it blossomed into a flower. By looking that flower budding from a stolen paniri of a plant, it gave me so much of pleasure, as if I have discovered something. And it gave me so much of delight that now I'll be able to fulfill the desire of my grandmother by offering her flowers for her puja. That is the impression which I still have in my mind. And I love the plants. I love the flowering plants so much that they have become part of my life. You see, when I was giving option in my M.Pharm course to Dr. Kishan Singh, I had opted for pharmaceutical chemistry. He asked me whether you will like to work on synthetic chemistry, which I am pursuing, or you would like to work on phytochemistry. I said, sir, I will work on plant chemistry. Later on, when chandonium was discovered, he once told me, good, if you have opted for synthetic chemistry, maybe you were the co-investigators of chandonium iodide. Sir, I don't regret my decision. I still feel that molecules of chandonium iodide like can be produced from the plants itself. I am so passionate about the plants. So, dear friends, I think I am taking too much of your time, but this is one message which I want to give. And for the sake of, the future generations of pharmacists, that we should not ignore the role of plants in our curriculum. There is a lot of work to be done. Hopefully, many molecules like reserpine, many molecules like vinbrastine, many molecules like taxol or artemisinin are hidden behind the area of biodiversity. Thank you very much, Dr. Satvinder and Dr. Anuja, for giving me this opportunity to talk to my fellow teachers. And I congratulate you and congratulate the management of GHG Khalsa College of Pharmacy, which is one of the premier institute of pharmaceutical education and research in Punjab, and to be associated with this function. If the time permits, then I would like to talk again, giving a full-fledged lecture of our own heritage in the discovery of general discovery of India, which has been recognized worldwide, and our pharmacy students, they are ignorant of that. I'll talk on we are celebrating 75 years of our independence, and we are celebrating Amrit Mahotsav. I would like to bring to the knowledge of our pharmacists that how glorious was science in older times. You see, there was, universities like Nalanda and Patliputra. There, the scholars from all over the world, they used to come and study there. It was during the invasions of Mughals that the Nalanda and other, they were destroyed. There were, contribution of our old Shishruta, who is considered to be the first surgeon doing the plastic surgery of nose. He was the discoverer of 31 surgical instruments. And this fact has been recognized well by the foreigners. See, there are quotes from Albert Einstein, there are quotes from eminent scientists of the world, of the bygone areas, which recognize that the contributions of Indian science, they are still relevant to us. Thank you very much. Thank you very much, friends.
Thank you so much, sir. It has been a pleasure to spend 10 years with you as a colleague and as your student so many years. And I would like to share here, I call sir encyclopedia. So thank you so much. for being with us today.
Thank you. My pleasure. My pleasure.
Thank you.
Thank you.
Thank you, sir. Thank you.
Thank you, sir. Thanks a lot for your kind words and information. So we always like to hear from you. It will be a very great opportunity for us to gain knowledge from you, sir. So thank you very much.
Well, at the end, if you have, time left or a space, I would like to dwell upon the ancient discoveries which have been made in Indian scenario, right? Thank you very much.
Okay, sir. Thank you. So it's time to felicitate Dr. V.K. Kapoor. So kindly accept our token of gratitude, sir.
Thank you. Thank you so much. I'm not very well versed with the, mobile or the computer system. That's why I am not able to either see you or show my face to you.
Okay, sir. No issue, sir. Sir,
I'm
we
very,
hear you. That's
I'm very much
enough for
handicapped.
us, sir.
I'm very much handicapped in this respect.
Thank you, sir.
But the
Thanks a lot.
other lecture, I will give it in a proper way.
Okay, sir. Definitely.
Another, news which I want to share with you and Dr. Satwinder is that today Dr. Renu Chadha, who superannuated from Punjab University, is going to join with Baddi University. That was the reason that I was there in her welcome and could not be with you in time, right?
Sir, congratulations for expanding your team of the stalwarts of pharmacy. I know you're going to enjoy working together. Congratulations. Please convey to ma'am also.
Yeah, sure. Thank you very much, madam.
Okay, sir.
Bye.
Thank you, sir. So we have amongst us Professor Maninder Karan. So Professor Maninder Karan is presently working as Professor of Pharmacognosy, University Institute of Pharmaceutical Sciences, Punjab University, Chandigarh. She has more than 25 years of teaching and research experience, has guided 8 doctorate, 4 are currently pursuing PhD under her, and 33 postgraduates. She has authored more than 115 research papers in reputed peer-reviewed international and national journals and has widely delivered lectures on various topics related to pharmaceutical sciences. She has also authored and co-authored several book chapters and books, and she is also working as a reviewer for reputed professional journals. Dr. Maninder has 56 monographs to her credit, of which 26 are pharmacopoeial monographs. She has filed 9 patents, granted 3 patents, and transferred 1 technology. 2 more technologies are ready to be licensed. She is editor of the Pharmacos and Institutional Journal and has completed 4 projects of Ayurvedic Pharmacopoeia of India and ICMR, and one of the most reputed outcome is formation of Darvi gel as a proprietary medicine. Dr. Maninder is currently mentoring an industrial startup project as coordinator cum consultant. She was formal expert member of Unani Pharmacopoeia Committee, Ministry of Health and Family Welfare, Government of India, New Delhi. She is also IQAC cell coordinator at UIPS. So I invite Dr. Maninder to deliver her lecture. She will speak on novel delivery options for herbals. Please, ma'am. Sorry, ma'am, you are not audible right now. Peace. नहीं मैम, मैम यू आर नॉट ऑडिबल नहीं है.
हेलो मैम. हेलो मैम. नहीं मैम ये आवाज
मैम आप एक बार So there is some technical glitch. So ma'am will resume again within 5 minutes. So I request the audience and delegates to kindly wait for 5 to 10 minutes.
हेडफोन इशू
Please mute करो अपने आप सारी बात चालू.
हेलो. हेलो.
Am I audible now?
Yes,
Yes,
ma'am,
yes,
yes. Yes, ma'am.
And video is also there?
Yes,
Yes
ma'am.
मैम.
Okay. So very good afternoon. First of all, to my most revered teacher, Professor V.K. Kapoor. Am I audible?
Yes, ma'am.
Okay, okay. It's my heartfelt greetings and a very good afternoon to Professor V.K. Kapoor, the most revered teacher I ever had, Dr. Satwinder, Dr. Parneet, management of Khalsa College, Guru Sir Siddharth, and all the participants. Today I'm here in this teaching profession at UIPS, and that's just because of Professor V.K. Kapoor. I always acknowledge his contribution in making me to join UIPS at Punjab University, and that is something, it is not only that I'm proud of that, I feel honored, but that is something that I would carry throughout my life, that we had such teachers who would always be so supportive and so helpful for the students, for the juniors, and for the society. I just happened to listen to a part of a talk of Professor Kapoor, and listening to him is always I would say it's a pleasure. The passion that he has for the profession. He himself has shared a part of his story, how he's so passionate about the plants, the herbals, the natural products. And that is so self-reflecting. If you see his contributions in the field of medicinal chemistry, in the field of natural products, in the field of Ayush, in the field of different branches of Ayush, ICMR. You just think of any organization, any association where you don't find Professor Kapoor as the subject expert. So it's always so proud to see him giving his immense contribution to the nation and to the society. So my heartfelt thanks to him. And before I start with my lecture, see, I always feel so blessed that we have teachers like Professor Kapoor who always tend to give due recognition to different disciplines of pharmaceutical sciences. You don't find such teachers, such pharmaceutical professionals everywhere. There is always something that people carry that, as he says, I'm more superior, this branch is more superior, that is more superior. But if I have to add another line to what Professor Kapoor has said, I would say whether it is pharmacology or it is chemistry or it is pharmaceutics, whatever it is, each and every branch is incomplete without the naturals. Everyone works in this field, but they don't want to acknowledge this field. So that is irony, but okay, leave aside that. So just coming to what I'm going to talk about is, so though I'm with a pharmacognosy background, but I have worked a bit in the area of novel drug delivery systems, especially related to the herbals. So there is no field that people coming from different, you can say, disciplines other than pharmaceutics cannot work in such fields. We have done work, we have filed patents, and our technology is ready to be taken up by the industry. So if you have the, you can say, passion to learn, passion to do things, there is nothing that is impossible. I would like to share, I don't know right now, all of you, all the participants, they come from which disciplines, but I just assume just like any other conference or any other training programs, there must be a very diverse group of participants covering a wide range of specializations. So what I'm going to talk about today is a very broad overview of novel herbal drug delivery systems. What is the current status and what is the future scope? Since people talk a lot about the novel drug delivery systems these days, and if we don't have the basic knowledge about what these systems are, we always tend to feel shy of कि ये पता नहीं क्या, पता नहीं कितनी कौन सी बड़ी चीज है जो हम नहीं कर सकते. But there is nothing like that. It's very, very, you can say, within our means. It's very, very within our capabilities that you can do a lot of work in this field and give your significant contribution to the field of pharmaceutical sciences. So can I share my screen? My slides?
Yes, ma'am, yes. Yes, ma'am, you're audible.
Okay, so here I have to click multiple participants or advanced sharing options. What I have to click?
Ma'am, you have to share the screen. Just there is a green folder.
Yes, there I click the window.
So, ma'am, share screen. After that, you have to select the window, and
Yes,
then share that. And the
yes, and then share.
okay.
Is it visible?
Yes,
Yes, yes, ma'am.
Okay. So here we just talk in brief about the novel herbal drug delivery systems, what are the current and future prospects. So straightway taking to the NDDS, which is the novel drug delivery system. What this NDDS is, this is a very novel approach to the drug delivery. And why it is novel? Because it has almost every capability to address the limitations of the traditional drug delivery systems. It can give us a very controlled distribution of the drug, and the drugs incorporated in the carrier system, which is the basis of the NDDSs, that is what we are doing. Or we change the structure of the drug at the molecular level. That is how we can have the better distribution or better delivery systems. Now, as I said, that it has capability to address almost every drawback of the conventional dosage forms, which are tablets, capsules, oral liquids, topical products, to name a few. So what these drawbacks are? Very simple. They come with poor bioavailability, which can be on account of any of the features. They are normally not very good compliant to the patient, very poor patient compliance. Reason being, majority of them come with high doses, repeated doses, and sometimes it is the dosage form also which is not acceptable to the patient. There are very increased chances of missing the dose of a drug. And this is especially for those which have a very short half-life or for which frequent administration is necessary. And missing the dose means not able to maintain the therapeutic levels. There are very high fluctuations in drug levels with the traditional dosage forms, and there is always a chance of precipitation of adverse effects. And this is more so when we have the drugs with very small therapeutic index, and particularly when there is some over-medication. And it is just not possible to avoid these fluctuations, which leads to either under medication or over medication. And what happens in these is a very typical plasma level concentration of the time profile is obtained, which makes attainment of the steady state condition very, very difficult in case of conventional dosage forms. So why is there need of these NDDS systems? Simply, we need to optimize the therapeutic effect of the drug. We need to have a very convenient administration and dose also. It is important to enhance the shelf life cycle or stability of the product, to improve patient compliance, to target drug delivery. It must be delivered at the right target. To facilitate biological drug delivery, it is very, very difficult to have the conventional dosage forms for biologicals. So there we have this particular system which is able to give us the products which can carry the biological drugs, and to maintain the drug concentration within the therapeutically effective range, which is very much needed for novel drug delivery systems. So now coming to the novel herbal drug delivery systems. See, men and medicine are inseparable from time immemorial. You all know this is a very, very age-old practice. जहाँ तक हमें सोसाइटी का, समाज का, एग्जिस्टेंस का पता है, वहां तक we have the documented proofs that whether it is initially the animals or then humans, they have been using the plants. And if you happen to see the animals, even now, see the monkeys, they're nibbling some plants. That is what we call as zoopharmacognosy. They have a special inherent knowledge in identifying which plants are good for their health and which are toxic. You just see animals grazing in the fields. You will find them eating some weeds or some crops, leaving others. Now, herbal formulations are rather, before herbal formulations, I would say herbal medicines are largely made from the whole plant materials, their parts or products. That is what we all know. And the herbal formulations are made from the plants or their parts, their extracts, their active concentrates, or they can be with or without the excipients. And they are formulated into some uniform composition medicinal products. Now, the scientific method by which the plant bioactive concentrates are processed into safe medicinal products comes under the herbal formulation development. So these herbals, including the phytoconstituents, including the phytopharmaceuticals that we get from nature, they consist of a full range of variety of biological therapeutic activities with them, by which we are able to treat various diseases, including the chronic diseases. But there are various challenges that come along with this. The challenges of herbal medicines and herbal formulations are lesser aqueous solubility, poor permeation, and lack of target specificity. Now, over the nearly more than past 2 decades, significant advances have been made related to the development of novel drug delivery systems, both for herbal products, extracts, and phytoconstituents as well. So these novel herbal drug delivery systems, they have opened practically a range of new vistas for the delivery of herbal drugs. How? Because they can be delivered at the right place, in the right concentration, and for the right period of time, they would stay in the body. And they also gives a scientific angle to verify the standardization of herbal drugs. So this means the herbal drugs as of today can be utilized in a better form with enhanced efficacy when we incorporate them into modern dosage form. So novel herbal drug delivery system is a beautiful system of integrating the traditional system into the modern system. And when the two come together, the output is, the result is excellent. So there are different modern approaches, so many approaches which can be adopted. And one of these approaches is the NDDS. A large number of these systems, including the solid lipid nanoparticles, phytosomes, liposomes, microspheres, and many are nowadays there, which can be designed and which can be applied for developing a novel formulation. And all the available novel systems generally are able to overcome the challenges which come with herbals and phytoconstituents. So these herbal drugs in the form of NDDS are delivered in a suitable formulation, keeping in view the safety, efficacy, and acceptability among other factors. When we talk about herbal drugs, they are extremely popular in the modern world, especially in the developed world and also the underdeveloped countries. These are the ones which are known to cure a variety of diseases with less toxic effects, better therapeutic effects. But as I said, that they come with many, many limitations. Couple of limitations we just discussed a minute back. Now coming to what are the other very specific limitations. One of the key feature is their instability in the highly acidic pH when we take them, the drugs orally. The liver metabolism. And these are two key features which can lead to the drug levels either below the therapeutic window, or there would be no therapeutic effect, or they can increase the levels beyond the safety point. Now, how this happens is that when we are taking the extracts or the drugs, crude drugs in totality, they are largely being metabolized in the liver, where we have metabolizing enzymes. If these enzymes, they happen to metabolize the drug more than the required, then what happens is their excretion from the body would be faster. They would not be able to give you that therapeutic effect which is desired. However, if it is lesser than the required, the drug is likely to stay for more time in the body. And there can be such situation that more of the metabolic products which are not safe, they stay in the body.
Sorry to disturb you, ma'am.
Yes.
Sorry. Ma'am, आपकी slide presentation move नहीं हो रही है. एक ही slide पे stagnant है.
Because I'm talking on this very slide only.
Okay, okay, ma'am. Okay.
So I'm saying more things and there is less on the slide.
Okay, ma'am. Okay, thank you, ma'am.
So incorporation of the novel drug delivery technology simply minimizes the drug degradation or pre-systemic metabolism, and also it minimizes the serious side effects which are likely to happen by accumulation of drugs to the non-targeted areas, and it improves the ease of administration. Now, this is very important for the pediatric and geriatric patients. Now, for keeping these things in mind, that means one of the foremost factor is to have a very good bioavailability. And these natural products, herbals, they must have a good balance between hydrophilicity and lipophilicity, which normally is not possible, especially with crude drugs or extracts. And simply because of their complex nature. There are a large number of constituents which have good water solubility, but they have very poor absorption because of the large size of the molecule, because of the poor diffusion, because of the poor miscibility with other materials which are present around, and this limits their ability to pass across the lipid-rich outer membrane. So the nano-sized drug delivery system have a potential future for enhancing the activity and overcoming the problems which are associated with plant medicines. There are a number of plant constituents like flavonoids, tannins, terpenoids, which have shown enhanced therapeutic effect at similar or less dose when they are incorporated into NDDS system. So there is a great potential in development of novel drug delivery systems for valuable herbal drugs as it proves much efficient and economical. So keeping these in mind, next we'll talk about, with this background I would say, we will talk about the current and future prospects. Now, as far as the current prospects are concerned, we all know that since ancient times, herbal plants are utilized to treat some of the very distinctive ailments. And their uses is, of course, on account of their availability, accessibility, inherited practices, economic feasibility, and perceived efficacy. So Ayurveda, one of the oldest and richest healthcare system. In recent times, developed nations are practically turning to the utilization of traditional medicine systems. And as indicated by WHO, relatively 65% of the total population use plants as therapeutic agents as their main course of healthcare. And you all know that these days, the nutraceuticals, the health supplements, the dietary supplements, they are so much in demand. And if you see the statistics, nutraceuticals and especially the nano phytopharmaceuticals are going to dominate the market in coming years. And nearly 25% of all drugs, out of which more than 75% is for the anti-cancer agents, they originate from plants. So, though we have their good place, good status at various levels, but yet there are many challenges, and challenges are same, that because of their inherited properties or because of their nature on account of complexity, which comes as a big hindrance to convert them into modern dosage forms. So a procedure of designed phytochemicals is now available in the form of NDDS, which not only improves the solubility, enhance the bioavailability, there is enhancement of cell penetrability, proteolytic stability, and half-life of the plant biomolecules. Throughout the world, there is a great push in R&D to focus on the development of new creative and innovative delivery systems for plant-based drugs. And these constituents, majority are dominated by alkaloids. You think of any field, pharmacological field, where we do not find the usage, the commercial usage and utility of alkaloids, triterpenoids, flavonoids, steroids. And just to share with you that the idea of herbal-based novel drug delivery systems was first conceived by a company Indena from Italy, who first created the phytosomes for a very popular drug from Europe, which is Silybum marianum. They developed the phytosomes. Now, this particular technology of phytosome novel drug delivery system is a patented technology of Indena, and that was the starting point of novel herbal drug delivery systems. So there are different components of how they are structured, how they are channelized, and amongst those components, one of the main component is, since we are now talking about the such system where we can incorporate the herbal drugs, and that something is the carrier. So the novel carrier is a very critical point, very crucial to make a very stable herbal nanoformulation. It must fulfill two essentials, must deliver the drug at a rate directed by the requirements of the body over the period of treatment, and it must channel the active substance of the herbal drug to the site of action. Now, conventional dosage forms, including the delayed release dosage forms, cannot meet these requirements. So in phytoformulation research, the advantages of developing dosage forms, including SLNs, nanoparticles, nanocapsules, liposomes, is not only to improve the solubility and bioavailability, it is also to improve the pharmacological action, to protect from toxicity, to have a stable product, and to have a sustained delivery at the desired rate, and protection from the physical and chemical degradation, and so on. So accordingly, the nano-sized novel drug delivery systems have a potential future for upgrading the action and defeating issues related with plant constituents. So I'll just skip this is same. The necessities of novel drug delivery systems over conventional herbal systems, besides improving the bioavailability and permeability, is to have a much smaller size of the particles. That is why we call it as nano, so that it can reach the target site at the desired rate and in the desired concentration. It can ensure the localized delivery. It can provide us the uniform dosage form and various forms of the extracts which otherwise are not able to be delivered using the conventional dosage forms can be delivered through nanosystems. Now, this is just a representation of various novel drug delivery systems of herbals which have been used over the time and developed, right from nanoparticles to microemulsions, dendrimers, solid lipid nanoparticles, ethosomes, liposomes, and others. And here you can see the advantages which comes with these systems. Since I'm not going into the details of each of these systems, that is not in the preview of the present lecture, just to make you, or just to give you a brief information, excuse me, the bioavailability enhancement is on account of increase in solubility and there is more membrane diffusion. Improved stability is because solubility increases, so there is more membrane diffusion. Biocompatibility increases and we have more biodegradable and more biocompatible system. Topical transdermal delivery, targeted delivery is what we get using site-specific delivery. We can have both zero order as well as sustained order release. Dose reduction, which is very, very key component that comes with NDDS. And dose reduction comes with not lesser therapeutic effect, but a better therapeutic effect and the lesser side effects. Toxicity is minimized. Pre-systemic metabolism is avoided and patient compliance is improved. So coming to the current developments, since it is a novel way to deal with medication and India has a vast knowledge of Ayurveda, so in any case, the formulations which have so far utilized administering herbal drugs to the patient are conventional. Now we have this technology, which when coupled with the Ayurveda can help us to have a large number of traditional systems to be used in the modern system of medicine. So it is very critical and important to know the significance, how it is done, whether it is actually feasible also to integrate Ayurveda or other traditional systems into the modern system or not. There were many concerns in the past regarding herbal medicines, and they were practically over all these years were not considered for improvement. And the reason was absence of scientific justification, processing difficulty, extreme problems associated with standardizations, quality controls, extractions, isolations, and identification of individual constituents. When we have something which is so complex that hundreds, thousands of constituents are present in the given system. Notwithstanding, the present-day phytopharmaceutical research can resolve the scientific requirements. For example, determination of pharmacokinetics. How much the dose, accurate dose is required. We can establish the mechanism of action. We can determine the site of action. And then we can incorporate those into various nanoforms. It is not that these systems comes with all advantages and positive aspects. They also come with a number of limitations. The first and foremost limitation is poor storage stability. Now, if we look at in the previous slides, we say that NDDS is more stable than the conventional dosage form. But it also has a limitation of poor storage stability. How come? It is because if we do not develop, if we do not have the knowledge that the system that we have developed is stable, we do not perform the studies that it is a stable formulation, naturally it would come with poor stability. There would be any kind of degradation, or there could be any kind of changes which happens on account of different factors to make the given system unstable. And if we do not have knowledge that what we have developed is, and that is the key thing to develop a stable nanosystem. If that is covered, it comes with poor encapsulation efficiency, and that is very much true, especially when we talk about the plant extracts or the phytopharmaceuticals. This is not a very big problem when we talk about the single molecule, whether it is phytomolecule or it is API. But encapsulating efficiently good amount of the active material is very, very important. अगर उसमें encapsulation ही efficient नहीं है, it would just not be possible to have the desired therapeutic levels. The production procedures are quite lengthy, and when it comes to herbals, they become much more lengthy because we are dealing with a very, very complex system of herbals. And if by chance some chemical cross-linking is involved, then there is always the possibility of the active components getting inactivated. The better understanding of metabolic pathways is important to ensure the safety of nanocarriers in clinical applications. The complexity of conducting clinical research in phytoconstituents toxicity, the herbal toxicity, the plant extract toxicity, as well as safety evaluation. It is a very, very complex phenomenon. We can observe these in humans, but these are very, very scarcely available in human. The clinical assessments which are required for the herbal drug potential of phytoconstituents incorporating these formulations. Then a very important factor is the regulatory requirements which are required for phytoconstituents, extract, and interaction with other medicine. So these are various limitations, but these limitations should not be the hindrance in coming up with novel formulation. अगर हम conventional formulation से novel formulation तक आए हैं, उसका एक रास्ता clear हुआ है, तो वो आगे से regulatory का रास्ता भी clear होगा. So future study is required on explanation of metabolic pathways and the evaluation of elimination routes and their kinetics, which are very key components required for the regulatory approvals. Take this. Advantages I have largely covered. So now this simply is, these are the different kinds of formulations, Hubble formulations, which are available. We have liposomes, phytosomes, nanoparticles, and many more. Coming to, just in brief, I'll show you what are liposomes, where we have the microsite sphere. This is design. We have a liposome, we have a nutrient. There are two heads. I'm not going, I'm sorry, into the details of these, but I would just switch over to what are the advantages of liposomes. The solubility enhancement, bioavailability enhancement, there is a program targeting, there is prolonged duration of action, so we can have sustained release product. So as they are lipoidal in constitution, they enhance the tissue macrophageal uptake of the entrapped constituents. And the stability associated problems can also be solved. Absorption and disposition of the constituents can also be tailored. Disadvantages of liposomes: low water solubility, high production cost, short half-life. Sometimes phospholipids undergo degradation, especially oxidation and hydrolysis type of reactions. There is leakage and fusion of encapsulated drug or molecule. This is just to give you some of the examples of liposomal herbal formulations, where we have pure molecules like quercetin to a mixture of compounds, which like silymarin is there. And there are many more examples available in the literature, and these are the ones which are commercially available. Then we have phytosomes. As I said, this is the patented technology of Indena from Italy. And so this is the structure of the phytosome, where again we have a phospholipid, there is a drug, and there is a very key difference between, I'll show, between the liposomes and phytosomes. If you can see this slide, on the upper side there is liposome, where this green part is the phospholipid, and it is entrapping the drug molecule in the central part, in the central core of the cavity. Whereas in case of phytosomes, the phospholipid and the drug, they integrate with each other in a very specific ratio. And that is how then the complex molecule of phytosome with drug aligns itself. And that is the basic difference. So advantages, and there is huge pharmaceutical scope. Coming to the merits of phytosomes over conventional. Again, bioavailability is dramatically enhanced, and it enhances the permeation of non-lipophilic botanical extracts. The formulation of phytosome is quite safe, and all active components have been approved for pharmaceutical and cosmetics use. And due to high bioavailability, phytosome is being largely used to deliver liver protecting flavonoids. That is what I mentioned. The Silybum extract, purified Silybum extract, Silybum as a phytopharmaceutical, Silymarin as a mixture of pure compounds from Silybum. That is something which is known globally for its efficacy in protecting the liver, and it is available as such. Uska powder bhi, uski dosage forms bhi, uski different conventional dosage forms bhi available hain. But what we have today is the excellent modern NDDS systems for various forms of Silybum, and one of the best selling plant globally, especially in the Europe and Western countries. So, here we have some of the more. We have ginkgo, all of you know, green tea phytozoans are there, ginseng phytozoans are there. And these are the ones which are so much popular because of their, you can say, enhancing the immune activity and others. Just excuse me. Hello. Movie. Acha? एक सेकेंड. तो फिर मैं इसको उसमें नहीं प्रेजेंटेशन पे ना करूं, इसी में कर दूं, इसी में रहना दूं. अच्छा ठीक है, चलो. So I was saying that these are some of the very well-known examples, and in this table I have just highlighted the examples of some of the very well-known plants and you can say herbals, plant constituents, especially the ones which are used as nutraceuticals, which are used as health supplements, which are used as dietary supplements. So they are so much in demand and they are so much in usage, especially in the Western and European countries, that their popularity is just unimaginable. इतनी इनकी popularity है और इतनी इनका usage है. So another is the nanoparticles, which are largely the solid colloidal particles, and we have the polymeric materials which are used extensively for the preparation of these nanoparticles. And I'll just mention a couple of, not be going to this particular slide, that these are the various types of nanoparticles which can be developed for various herbal formulations. And out of these, the most important is the solid lipid nanoparticles. So here you can see it is just an example. I'm not going into the chemistry of these nanoparticles, and just moving on to, in fact, this particular presentation also carries how and we can make different nanoparticles as well. But since I have to restrict my talk to the current and future status, so large part of that I have shared that the current status is that yes, now we have a system which we can very much develop, taking into care their usage, their utility, their applications over conventional dosage forms. Much of the limitations which comes with conventional dosage forms can be solved using the novel drug delivery systems. But it is not that they are so easy to be developed. We must understand the nature, the chemistry of these herbals before actually putting that exercise and trying to develop a system. अगर हमें plant chemistry की knowledge नहीं होगी, तो probably it is just not possible to develop any of these systems. Important to know that, important to understand what are the things we are going to use to develop a system. Otherwise, we will just be losing and we will just be wasting not only various resources, but time also, energies also, labor also, everything. And ultimately, what we would have in hand without analyzing is a very, very poor formulation. So those things needs to be taken care of. And the limitations, I have already shared the large number of limitations which comes with NDDS, but they soon will be, you can say, overcome, keeping in mind if we have the understanding, if we have the knowledge, and if we are quite aware about those limitations. And as far as we talk about the future, since a huge number of formulations are already now in the market, so and so that the drugs like anti-cancer agents, paclitaxel, is nowadays available as a nanosystem. And in much of the oncological fields, instead of using paclitaxel as a pure molecule, that nanosystem is being used for the reason it has been able to produce a system where comparatively much lesser dose of paclitaxel is required to reach the therapeutic effect. So when we are using lesser dose of the chemotherapeutic agent, obviously the side effects are going to be much lesser. Another beautiful aspect of using this system is combining different things into one system, whereby we can achieve the desired targets, keeping in mind some of the, you can say, weak properties of the main system, and covering that using a co-substance. Again, I would just give the example of, say, paclitaxel only. A lot of work is being done and has been successful also, where once again, you all know that there are P-glycoprotein inhibitors, which are responsible for taking the drug out of the cell. So when we talk about the chemotherapeutic agents, it is important that they reach the desired concentration, the desired level. But these P-glycoprotein inhibitors, they tend to take that active molecule out of the cell very fast. That is another reason of using such a dose that एक जो appropriate amount चाहिए cancer cells को वो बना रहे. So if we are able to use something along with paclitaxel, which acts at the level of P-glycoproteins, and it is not able to, and it is able to protect the P-glycoproteins to act upon the active molecule, it acts as an inhibitor, then what happens is the optimum dose or optimum concentration of the chemotherapeutics drug would be available at the site. वो वहां से बाहर नहीं जाएगी, सेल से बाहर नहीं जाएगी, और जब वो बाहर नहीं जाएगी, उसकी ऑप्टिमम डोज वहां पे पहुंचेगी, तो उससे क्या होगा कि हमें जो एडमिनिस्ट्रेशन भी करना है डोज का वो भी कम करना पड़ेगा, बिकॉज वी आर एबल टू रीच ऑप्टिमम लेवल विद इन द सेल्स. So we have such systems which otherwise are not possible. अब उसको combine करना या उनको system को इस तरह से use करना is not in the capability or not in the preview of conventional dosage forms. But that is something which can only be done using such nanosystems. So it is, I would say, the future prospects of novel herbal drug delivery systems are immense. They are so encouraging. If you see the literature over past 20 years, the drug delivery development of herbals is so encouraging, and there is incredible capability, I would say, of herbal delivery to be safe, to be effective, to be convenient, And we can have the economically viable system if we tend to make efforts in that direction. So otherwise, in any case, all these studies, I would not say that they are very, very advanced stage. Some limitations, some exploratory things are still going on, but that is the future prospects, that there is a scope of active expansion of this field. Huge amount of work can be done in this field. So, and it is widely expected that utilization of herbal drug delivery will make novel therapeutics, and it will just change the prospects of phytopharmaceutical industry. And the development of phytoconstituents delivery can not only help in achieving the consistent quality and bioavailability, but the therapeutic effects of herbal drugs and products would also be enhanced. And different phytoconstituent delivery systems are being researched in the research institutes, in the industries, in the organizations, in every possible place. These are being under active research, and many of these are either in the development stage, many of them have reached the clinical stages, and many have already reached the market as well. So there are numerous areas of interest where there will be effective and safer targeted therapeutics for a numerous of clinical applications. And why this is getting more and more feasible with each passing day is because as of today, we have huge knowledge and huge improvement in the availability of a vast variety of materials which are required to make this system, a huge variety of equipment that is required to make these systems, and an ever increasing number of herbal drugs will undoubtedly be formulated in the future. That is what I feel, and that is what I wish also, that the world, the society sees the immense potential and the immense contribution of herbal medicines, which doesn't stay just with the traditional system, but it becomes the most integral part of the modern system as well. So with that, I close my lecture here, and thank you so much to the organizers. Can I stop my slide?
Yes, ma'am. Yes, you can.
Okay.
Thank you, ma'am. Thanks a lot. It was very informative session. So I request the delegates, if they are having any kind of query, they can message us in the chat box. So we'll unmute you. I think there are no queries, ma'am. It was so well explained.
No, I think just because I tried to give a very basic information, and I just want that if I can generate some interest amongst the participants to work more and more in this field.
Yes, ma'am. So it was
Hello,
very.
ma'am. It was very interesting.
Hello, Dr.
And a
Satvinder, how are
pleasure.
you?
I'm good.
Nice to see
It
you.
felt so good listening to you after so many years.
Thank you
And
so
it's
much.
always a pleasure to be attached to teachers. Thank you so much for
Thank
being
you so
with
much.
us.
Thank you so much, Dr.
Thank you so much.
Satvinder.
Thank you, ma'am. So it's time to felicitate Dr. Maninder. So, ma'am, kindly accept a token of gratitude.
Thank you so much.
Thank you, ma'am.
Thank you.
So it's time to conclude this day's sessions. So tomorrow we will meet at 11 o'clock. So tomorrow there are 3 lectures. So we are going to conclude. I would like to thank all the speakers of the technical sessions and all the members of the governing council for encouraging us to for organizing such kind of FTP programs. So thank you. Thanks a lot. So we will meet tomorrow at 11 o'clock.
Okay, thank you from my side for inviting me and to be a part of this program. My thanks to everyone
Link
here.
will be sent to the
Thank you,
WhatsApp
ma'am.
group.
Thanks a
Thank
lot.
you.
So the attendance link and feedback link will be sent to the WhatsApp group. So delegates may find that there.